Welcome to Pratidhwani, where we try to humanize science. I'm your host, GV Pawan Kumar. It is my absolute delight and pleasure to introduce you to my guest on this particular episode, Professor Sudipta Sarkar. Sudipta is a professor at Indian Institute of Technology, Gandhinagar, since 2012. And he took his undergraduate and master's degree from the famous University of Calcutta with the physics department there. Subsequently, he was a PhD student at Aayuka, Pune, and had an excellent, experience during that time, having worked with Professor T. Padmanabhan. Subsequently, Sudipta spent some time in the US, in the University of Maryland, and also some time at Institute of Mathematical Sciences in Chennai. And Sudipta is an expert on gravitational physics, including some very fascinating questions what he has been asking related to black hole physics, particularly on thermodynamics of black holes. And his recent work also includes some very pertinent questions related to entropy and also some specific aspects related to the event horizon and the field theory in the curved space time kind of a situation. There are so many interesting questions what he has been involved in, and also Sudipta has a very interesting flair of also not only to express his opinion through wonderful writing, which I have been actually also an audience to, and also his interest in history and philosophy of science, physics, and generally overall aspects of looking at the world is something I really admire, and it's a pleasure to invite Sudipta on Pratidhwani.
Well, thank you for considering me. Yeah.
Yeah,
I've been following your podcast and your discussion with many. Some of them are my good friends.
yes.
And I must say it's a great work.
Yeah, thank you. Thank you very much. In fact, I should really thank people like you who really actually are very generous with their time and also with their thoughts. Sudipta, we'll get started with your origins. Just let us know about your intellectual kind of upbringing, right from the school to the stage where you are. Just give us a kind of an overview of the trajectory of your career. Yeah.
Well, you can say that I'm from pure Calcutta. Okay. And I should be very specific. I'm from South Calcutta. Okay.
Okay.
I started my journey in a school called Sarkar Institution. In those days, almost all schools were government school. Most of us grew up under government institutions. This was also a government institute, government school. Uh, my father, used to work in a bank. He was a state bank employee. Mother was housewife. Uh, uh, so I grew up in an environment can be broadly classified as a typical middle class Bengali environment, where a lot of Tagore, lot of discussion on art, literature, and politics. My father was deeply interested in politics, as well as he was also interested in rational movements, many other things. Okay, and he introduced me at my very early age science fiction books. So
Nice.
I was very lucky that there was this Bengali translation of entire Julavan or H.G. Wells were available at that time.
Nice.
So I read them, I mean, maybe in class 7 or class 8, of course, in Bengali. There was an amazing guy called Adrish Burman who translated these things into Bengali from the English, of course, not from the French. But the translation was, now when I read the English ones, I know that the Bengali translations were quite good. Okay. But this was, in some sense, my first introduction to modern science, through science fiction. Okay. I still a great fan of Jules Verne.
Nice, nice.
So, so on this ground, in class 8 or 9, if I remember correctly, I first got a Bengali book, a translation of Stephen Hawking's Brief History of Time. It's in Bengali called Kale Sankipta Itihas. It's literally
Nice.
Brief History of Time.
Time, yes, yes.
I mean, it's actually quite remarkable if you think that now that there was guys at that time. This thing, I think this book is translated by somebody called Shatrugna Sengupta, who was a science journalist, if I remember it correctly. And these books are the first time I heard something called uncertainty principle with Bengali. Okay. So I know all the Bengali names of these principles. Okay. Okay.
Wonderful. Because that's something very fascinating to really
Yes.
have it talk about. Yeah, yeah. Please go ahead. Please go ahead. Yeah.
So I was interested in mathematics mostly, not much on physics. Okay,
Oh,
because
okay. Okay.
at my family it was considered that if you know mathematics well, you will be considered a good student. So
Yeah.
the aim was to get 100 and 100 in mathematics. Not that I always got 100 in mathematics, but that was like aim. Okay. But fortunately, I took mechanics. So in 10th, we have 9th and 10th, we have to take a special paper. We used to call additional. Just a name at that time. So I took mechanics as additional. So mechanics basically means that it used to be Newtonian mechanics, like
Mm.
motion of things. Some no calculus was, of course, there at class 10, but it used to talk about rigid body, accelerations, inertial frames. In some sense, that's the my first introduction to a glimpse of what is modern science. And
Nice.
I was fascinated by, and I decided that I will pursue science, whatever. So my college education took place Ashutosh College, which is a
Mm.
college under Calcutta University.
Named
Uh,
after Ashutosh Mukherjee,
Ashutosh Mukherjee, actually,
the
yes.
great. Yeah, yeah,
It's
yeah.
a very well-known college in the South Calcutta. And there I had the privilege of some very good teacher, particularly Professor Moinak Gupta, who was a
Hmm.
physics teacher, and he was very well known among the students. Okay.
Students, yes, yeah.
And uh, so Professor Gupta, I remember that. So he had this hierarchy in some sense. So like, certain students, he will give certain problems. If you do better, then the standard of the problems will increase. So one day he told me, okay, you're interested in physics. And I was at second year of my BSc. But he told me that if you're interested in electrodynamics, you must read Landau.
Mm.
And he bought the Landau's book from his closet and showed it to me. I mean, of course, not that I followed anything at that time, but this encouragement was there that you
Mm.
should try to read good quality books. And that I think is an extremely positive
Understand.
encouragement. Yeah. So after BSc, I decided, first of all, I decided I'll not do engineering. That
Mm.
was there in 10 plus 2. And thankfully, there was no family pressure.
Mm.
Okay, my
Mm.
father was very, very open, and and my mother also, that they were open that whatever I want to pursue, there's absolutely no. In fact, there was encouragement.
Nice.
My mother was very happy because one of her dream was to me becoming a college teacher. Okay, so many times
Nice.
told, oh, it will be great. You will go to a college, and that will be
Mm.
amazing. In any case, so I went to University of Calcutta, the Science College. Well, you know that Science College has a great heritage.
Great.
The
Yeah, yeah,
building
yeah.
itself is an amazing building. The physics department in Rajavaja Science College. It's named after Tarakanath Palit, who
Mm.
actually, the department started with his donation. Okay.
Oh, wonderful.
Uh,
Mm.
Now, when I went there in 2002 to 2004, this 2 year MSc, it was probably at its zenith in some sense. Okay. At least modern part. So we had great teachers. Like Professor Manoranjan Shah used to teach us statistical mechanics. Okay.
Mm-hmm.
Then Professor Anirvan Kundu, who just joined as a young guy. Okay.
Mm.
And he used to talk about all these renormalizations. Okay.
Mm.
Quantum field theory. It was exciting time. And then the most important influence at Science College for me was Professor Amitabh Rai Chaudhary,
Yeah. Oh,
ARC, as we know
yeah.
him. Okay.
Yes, yes.
And ARC, like, I mean, of course, he was a great teacher, but he also has his distinct style. Okay,
Fine.
style in speaking very posh English. Okay,
Mm.
I mean, it's no wonder you will be attracted to this guy.
Mm.
That this guy is
Mm.
really great. Okay, I mean, at that time, I'm almost convinced that I will do PhD with ARC. Okay. So that's
Mm.
what my goal. I went and talked to him that I'm interested in quantum field theory thing. And he told me,
Mm.
why don't you read neutrino oscillations and those things? Okay.
Mm.
At that time, I think he was working on those
Mm.
modules. So in Calcutta University, there was at that time, MSc has no project course or anything. It's
Mm.
just like plain vanilla 2 year MSc. There was not even
MS.
a semester process. Okay.
Okay,
Like full
okay.
year, you mug up and you take the exam at the end. Well, no, in retrospective, I realized that that system also had certain amount of advantage.
Exactly, exactly. Yeah, yeah.
It has certain negative connotations. Of course, it
Mm,
added too much pressure
yeah.
sometimes. But remember that we were free to read in our way without
Mm,
the fear of the exam. Like I had a very good friend, Nilanjan, me and Nilanjan. Nilanjan later became a string theorist at math science. So we used to do study together, quantum field theory. And since there was much less of a pressure of the exams were
mm,
a bit distant. So we could go and read whatever we want. It's like we used to
mm,
fight over with each other. Oh, this book is bad. This is a bad interpretation. We should understand this way. In semester process, I realized later that there's too much pressure of assignments.
mm,
It has its own value, there is no doubt.
mm,
But it sometimes hamper, I mean, some independent way of reading this
mm,
group collaborations. Okay, I have learned a lot from talking to my friends at that time, particularly Nilanjan, Shamohita. They were very good students. Okay, they were really good physics. So I almost decided that I will try to pursue PhD with Amitabh Raychaudhuri. Then what happened is that the final year we had this general relativity course.
mm,
Well, uh, in I actually remember that I was sitting in the library. So we had a small departmental library apart from the big library, and uh, I first time saw this in the library. The Mr. Wheeler Thorn. It was given as
mm,
a reference book because those days these books were costly.
mm, mm.
So of course, we could not have, and there was no online book. It is like beyond the horizon at that time. There was hardly anything. Okay.
Yeah.
So I started looking at the book. Okay. So, so the Mr. Method, of course, again, I have not understood what is written in the book in terms of mathematical content, but those boxes. So if you open Mr. Method, it has these boxes. So basically,
Mm,
what happened is that there is a chapter. In the chapter, there's a box where they'll talk about some tangential topic. So
nice.
sometimes more the chapter, reading the tangential topic itself is interesting. It
Interesting.
will
Yeah.
talk about some historical aspect of the
Mm,
general relativity. Who discovered that? What
mm,
happened? There is somebody discovered something else. Okay. So that has added to, I mean, something to it. So I realized that I'm deeply interested in this. I want to pursue uh, probably general relativity more than quantum field theory. Okay.
mm,
So what happened? So I went and talked to ARC that look, I'm very deeply interested in this also. What should I do?
mm.
ARC was really, really positive. So he immediately says, "Oh, if you want to do PhD in relativity, you should go and do PhD Aayuka with Paddy."
Wow.
He
Directly.
told
He
me, yeah,
told very clearly.
yeah, here's clear answer. He told me that there is Thanu Padmanabhan. And before that, I didn't know
Yeah.
about Paddy. See, on those days, the you also know that
Yeah.
the information access was much lower.
Absolutely correct. Absolutely correct. You're right. Yeah.
For example, I didn't know now, if I say this, people will find a bit stupid. I didn't know there are MSc programs in IITs.
Mm, yeah. Yeah. In fact, that was also a later realization, even for me. You're
Yeah.
right. Yeah.
So then a friend of me, a senior of me went to do MSc. Somebody
Mm,
told, oh, you can apply through this way.
mm,
So, so of course, since ARC told me, so I decided that I will try my best. And then, of course, we cleared just
mm.
exam. And then we went for Aayuka interview. And in fact, I remember that Aayuka interview was just the next day after my final MSc exam. So I came out of
Wow.
the exam, I directly went to the railway station. Okay. In fact, that was my first journey, long journey without my parents. Okay. First
Wow.
time. Okay. Yeah. So Ayuka, it was like, you come from a Calcutta university and then you suddenly see Ayuka. Okay. It was like, shock in some sense, a positive shock. There is something called research institute. Okay. And its infrastructure at those times, it was like, I mean, comparable to whatever I have seen. I mean, I was like mesmerized. Okay.
Mm,
I also have, okay, by the way, even before Ayuka, I think I had two, three places I have given just interview. And I must say that interview experience was not very positive. I was, of course, selected. But
mm, mm.
I thought that some of the questions are like, derive quadruple form,
Uh-huh.
derive the quadruple moment for this charge distribution, that charge
Mm,
distribution, which I didn't like.
mm,
So in Aayuka, my first interview board, Paddy was there. Okay. And then
mm.
the kind of questions they asked. Okay. I mean, so I actually remember what Paddy asked me. So he said, okay,
Okay.
put
Mm,
kx square as the potential of the harmonic oscillator. Tell me what happens to,
mm.
so immediately Calcutta University students, they mug up very well. Okay. So everything immediately told him. Then he said, okay, what about I put a x's cube term? Oh, immediately I
Mm.
said first order perturbation theory. Also. Then he said, no, 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 no. Remove that x square. Suppose it's x cube. How will you solve it? Okay. Now that's so he said, don't worry about it. You cannot solve it exactly. You cannot
Mm,
write
mm,
down, you cannot factorize now to there's the
mm,
A dagger. What do you do? Okay. Think of something. What do you do? So
mm.
I remember that somewhere somebody told me that if you cannot do something in physics, you should try dimensional analysis.
Analysis.
Okay.
Nice.
So I said,
Fantastic.
I will do dimensional analysis and guess the.
Uh,
So then Patty said, but how will you do dimensional analysis? I said, okay, I will assume that whenever h bar, whatever the power of h bar.
uh,
So I told him, look, in harmonic oscillator is n h bar. I will assume that whatever the power of h bar, same power of n will come.
mm,
Okay. So Patty was a bit happy. Of course, I
mm.
cannot justify it. Okay. But it was just, and he liked it. I can clearly see
I
his face.
see.
He liked it that I was trying to say something outrageous. Okay. But nevertheless, he was happy. So he made me do that calculations. Okay. Suppose it is, then what do you have? So the second interview was also very positive interview. So that's the first time I understood that I'm talking to people
Mm,
who are considering me as a individual. They are
nice.
not considering me something less. They're not making a
Mm,
judgment on me. And believe me, that was a very, very positive experience. That I
mm,
felt that I have learned
mm,
something out of the
mm,
interview process. Okay. Even today, I'll try to convince and control myself and train
mm,
myself that, of course, I'm nowhere near to those expertise. That
mm,
I try to take whenever I talk to students or I talk to take an interview, I try to follow that example. I remember that how much great I felt while
mm,
doing the
mm,
interview at Aayuka compared to some other places. Okay, I remember that experience and I try to implement it. Not that I always, I mean, everybody has limitations. Sometimes I also get angry in the interview. I do also. Okay. Well, so it was clear to me that the interview was very positive, to be honest. Okay. So I came out of the interview panel and then at the same night, we had a train. I think we came back.
mm.
And when I came back, I immediately understood. I got an email. Okay.
Oh,
That
very nice. Nice. Mm.
so and that's all. I decided I will not give any more interviews. Okay.
Fantastic. Mm.
Because in those days, I don't know, in just so you go for entire India travel. Okay.
Yes, yes. In fact,
Stop.
this is what you're talking about in 2009 sometime?
No, no, even earlier, old
Oh,
guy.
yeah, 2000, 2005,
4,
2004, 4.
2004. Yeah.
Oh, same here.
So you
Exactly.
remember you
What's
hop to different
after?
stations
Yes,
by
yes, yes.
second class sleeper
Yeah, yeah, yeah,
train.
yeah.
Okay.
Yeah,
Yeah.
you graduated at 2009. You're right, right.
Yeah.
You're right. Yeah, yeah,
So
yeah.
that was, so I
Nice.
decided no more. I got this offer. I'm not going anywhere. Okay. So and then I landed up in Ayuka. First day, there was a shock. Okay. Because Kandu told me, oh, so you passed JS, very good. So where is your net certificate? I said, I've not given net. I thought. Then it turns out Ayuka requires net exam also.
Ore Bap.
Okay, because it's a UGC institute. Now it's a
Ah,
disaster. Okay, because I have not even given the net
you
exam.
did.
I just came. Okay. So then they said, no, no, don't worry. Okay, we didn't inform you. But
Hmm.
how would I know? And
Yeah, yeah.
those things were a bit, fluid
Yeah.
compared to now. So they said, don't worry, you cleared the net within 6 months or something like that.
Hmm.
Okay, so that was fun. Okay, and first day was a shock.
Man.
Maybe they'll throw me out or something. Well, any case, so Ayuka, we were four people. Okay,
Hmm.
me, Sharanashur, who is now a faculty at IIA, and
Mm-hmm.
then Mudit Srivastava, who is faculty at PRL, and
Yeah.
there's be another person, Heman Bhattacharya. She is no more with us.
Oh, okay,
So it's
okay.
a very four people. Okay,
Mm.
those days it's like that, right? Only
Yeah,
few.
yeah. Few people join. Yeah, yeah.
So Aayuka, of course, it was a different experience. So this is first time we are in Pune, and you understand this is the time the globalization's effects are coming
Mm,
up.
mm, mm,
So malls came up. Okay,
mm.
you can see barista coffee. Okay, and Ayuka, you are exposed to people who know what is a coffee. Okay, I only know what is a Nescafe. Okay, so this is the first time I know people who know. You talk about percolators. Okay, coffee beans. I didn't know there are coffee beans. I thought coffee comes from bottle. Okay, okay. So it's a different world. Okay,
Nice.
and of course, the Ayuka Graduate School was very interesting because, to be honest, at that time I didn't like it
Mm,
because it was more astronomy,
mm,
okay, than theoretical physics. At that
mm,
time, I used to feel, no, why I'm wasting this time? I'm not going to do astronomy. There should be quantum field theory course. But again, only after this 20 years of in retrospective, I feel that just because those times I talk to people who work with
mm,
data, who work with statistics, now I have an advantage.
exactly. Oh, okay, okay.
Yeah.
Yeah.
So it's only in retrospective I have realized it. Okay.
Mm, mm,
That I know what is a three sigma detection means. Okay.
mm, mm,
Compared to my other theory colleagues. Okay.
mm,
Not saying they don't know, but I'm
mm.
exposed it to art before them. Okay.
5 minutes.
So that has really helped. So the people are giving talk about Bayesian statistics, likelihood function. There's all GW groups are talking about likelihood functions. Okay, they are talking about posterior versus priors. Okay, you hear all these debates. Okay, and then
Mm,
we learn by osmosis, right? In
yeah,
those
yeah.
environment. I must admit, at that time, I didn't realize that it's going to be positive. But today, I realize it that how positive experience it was. That I only didn't learn quantum field theory and general relativity. I learned also supernova shocks. Okay.
Mm,
So funny thing is that so I wanted to join Paddy. So I was told that you can only join Paddy if you do well in his course.
mhm,
And Paddy's course, okay, so he's taught general relativity.
yeah.
So
Famous course.
well, so of course he starts with left hand. He
Oh
come
man.
in between of the board.
And
The
then
chalk will pass to the right hand. He will start writing on it. Okay.
yes.
Later, I told Paddy, you do it deliberately. So Paddy will start laughing. Okay. It was like a some show is going on.
Goes on, yeah. I've heard him. In fact, even some undergraduate lectures he used to give in Paisa Pune. Fabulous. Yeah.
And his board work,
Yeah.
it's perfect. And this sometimes he has this annoying notation, like a vector, he will take
Ah.
A, and then niche there is a way we learn.
Tilda kind of.
Tilda. I mean, it's annoying sometimes, and then he will confuse you because he'll follow the Landau-Lifshitz
That's
notation.
it. Notation.
I, J, K are four indices, mu, nu are the three indices. Every book it is opposite. Okay. So I mean, well, anyway, but the first time you see that so Paddy was very, very careful in teaching. So while in the class, he will not talk about deep conceptual issues.
Mm,
But last 5 minutes, he'll stop and then he will, clean his hand and then he
mm,
will talk about a perspective of the class.
mm.
And then, no, it's sometimes it's like revealing. Okay,
Yeah,
there's
yeah.
you learn something which is like so the GR course was extraordinary. Okay, I mean, I thought, okay, this I have to do. Okay, all through my life. Okay, well, we did reasonably well, and Paddy agreed to take us as a project student. So these are the hurdles. So you first pass the GR course, you do reasonably well, at least what Paddy thinks is
Mm,
good. Then you become his project students. Okay.
mm.
So Paddy asked me, what do you want to do? I have no idea what do I. So I said, okay, I want to do Hawking radiation. And he said, okay. So he gave me this Hawking's paper
Mm,
and one of his review. He has
mm,
written this review. He told me,
mm,
why don't you go and read?
mm.
So I went and read Hawking's paper. Okay. Of course, I didn't understand anything. So 1 week later, I came to him and then Paddy. So he used to come to office at 10:30s, okay, around that.
Mm,
So you go and knock,
mm,
and Paddy will say, "Come in." And then
mm.
Paddy, may I come in? So you don't have to do any appointment or anything.
Yeah,
You
okay.
catch him at that time. So I told Paddy, I'm not able to understand anything in the paper. So Paddy looked at me and looked, but I understand. Why you're telling me? So he said, you have to understand it. Then he asked me to sit
Mm,
and he told me. So he has this explanation of backward light cone method.
mm, mm,
He said, what is the understanding? You want to know this?
mm,
Find things which are causally connected to it.
mm.
See, this is something I also see the students. Suppose you want to understand something, you go started reading the previous
Re-
literature.
exactly.
Where do you stop?
Mm,
So
mm.
Patty told me, no. You understand in a backward light cone method,
Wonderful,
things which are
wonderful.
causally connected, and that's all.
Mm,
So I completed project with him, and I gave a seminar, and he was, I think, reasonably satisfied with the seminar, and he wrote a report. In fact, we did some new calculations with Unruh detectors in de Sitter space. We never wrote it actually. Somehow,
mhm,
we never completed some of the calculations. I think it's publishable. But then what happened? Yeah, so I remembered that. So I wrote him an email. So Paddy, the project is complete. So
mm,
what do you think about joining you as a PhD student? So Paddy replied back immediately, like, come and meet me.
mm,
So I went and met him, and then he said, give me 15 minutes of pep talk, saying that, look, you understand if you do theory, the postdocs, you may not
mm,
get, okay, you should work on cosmology. Okay, then it is
mm,
easier, a lot of observations
mm,
coming. Then he told me, have you talked to other people?
mm,
Explored. Because he was a bit worried that I may not have explored things.
mm,
I
mm,
may not know what other people are doing. So I said, no, I have spoken to other people. There are
mm,
wonderful people, but I want
mm,
to do this.
mm.
And then he agreed. So that was a good experience. So working with Paddy was very interesting experience. But remember at that time, Paddy was also started working on this his emergent gravity paradigm.
Nice,
So,
nice.
so I was probably the first PhD student
Mm,
started working on it. So there was a great paper in almost 1992 or 94, I think, by Ted Jacobson, who
mhm.
shown that Einstein's equations can be understood as a thermodynamic relation at every
Nice.
point in space-time. This is a remarkable paper. So he
Mm,
could able to write Einstein's equations as like TdS equal to delta Q, a Clausius
mm,
relationship, with T, S, Q properly defined with some, justification. Okay. That these are really, one
mm,
can interpret them as temperature, uh, entropy. So this paper was a shock to the community that because it was clear that if it is true that uh, if general relativity is something like a theory of phonons, okay,
mm,
yeah.
mm, mm,
So why are we quantizing gravitons?
mm,
So maybe we should look for some statistical mechanics instead, where the emergence of the gravity will be same as thermodynamics come out of
come
statistical
on.
mechanics.
Yeah,
Okay.
yeah.
There's a different relationship between quantum theory of gravity and quantum gravity and classical gravity. So basically, the metrical degree of freedom will be now to be the fundamental degree of freedom
Quantitative.
quantized. Okay. So Paddy told me that look at it whether this kind. So at that time there was a lot of people working on beyond GR theories like higher
Mm,
temperature theories, scalar tensor theory. So he gave me a project that why don't you look for whether this paradigm can be generalized.
mm,
So Asim Pranchpei was visiting us at that time to Aayuka. So we team up. We wrote our first paper, and we show that this emergent gravity paradigm,
mm,
which Jacobson and Paddy started, it's not only restricted to general relativity, it transcends beyond general relativity to many other theories. It's a pretty general statement. Okay?
mm,
And at that time, it's created, I think, a reasonable interest. That,
yeah, yeah.
and that's the kind of PhD work, main crux of my PhD work with Paddy, understanding whether the emergent paradigm transcend
Mm,
beyond relativity or not. I also worked on semi-classical calculations, like
mm,
understanding corrections to entropy and this. And then I ended up with TED as a
Hmm.
postdoc. That was also a remarkable experience. Ted Jacobson was a great guy. I would say an excellent physicist
In Maryland,
in
right? If I'm
Maryland.
in University of
And
Maryland.
you know that Maryland had a great tradition of gravity,
Yeah,
starting from
yeah.
Mishner.
Hmm.
Rajyoti briefly was there.
Oh, is it? Okay,
Vishu
okay.
was there. Visheshwara was there
Vishweshwara, yes, yes.
as Mishner student. Okay.
Nice, nice.
At that time, when I went joined Maryland as a postdoc, Raman Sandram joined as a
Hmm.
faculty member from John Hopkins,
Hmm.
and it was a very what should I say, very department with a lot of high energy physicists, string theories, as well as pure gravity. And then Baylock, who was there, who worked on
Hmm.
the statistical interpretation of gravity. So a lot of interactions. Okay. So it was great fun to work on
Nice.
both professionally and personally also. Okay. And then I came back. I wanted to come back. I
Hmm.
got some other positions, but I decided to come back for math science because I started doing all this application. Math science, of course, Ghanshyam Date and Ramesh Kaul, two amazing
Hmm.
people. Okay. They were really, really great human beings. Date and Kaul, particularly the amount of help I have received for them
Hmm.
and
Hmm.
the things I have learned. So Ramesh gave a set of lectures on gauge theory, n equal
Hmm.
to 4 super young means. So I mean, so I must say that these are the things I was so fortunate that whenever I need something, I got it from my teachers. And
Nice,
these
nice.
lectures were very important for me because they have helped me to change my research
Hmm.
directions.
Hmm. Yeah. Yeah,
That's all.
that's wonderful, wonderful. Because I also see that across this particular trajectory, you started with this very fascinating emergent paradigm where you looked at some aspects related to thermodynamic, black hole theory, and then you have also kind of elaborated that and also expanded that interest.
That's
So, what are the things which actually were in your mind when you were trying to elaborate these interests, Sudipta? Of course, it is generally it's also an accident because you generally go to a place and you learn new things. But were you also thinking about certain directions in which you would want to prefer to go? Because I also have heard some of your very nice YouTube talks, including the rotating black holes and other kind of interesting questions what you have been interested in. Could you just let us know how you have been able to diversify? Because that is a question as a scholar one is
it.
always interested in. And if you can let us
So
know.
I must say that towards the end of my PhD, uh, I got fascinated with ADS-CFT.
Mm-hmm.
So that was, and that is because partly of, so for my life, intellectual life, there are people who played a very important role. So Maulik Parikh joined Aayuka as a faculty member. Maulik was a student of Frank Wilczek. Then he did project postdoc with Brian Greene and I think Tufts. It was a very illustrated career. He joined, but he was a very young guy at that time. Okay, and he was very friendly. So he gave a topical course on ADS safety. Uh, it is Maulik who introduced me to the language required to learn. For example, I did a course on conformal field theory with him, something called Yellow Book of
Yellow
Conformal
book.
Field Theory. Everybody did.
I've,
So
I've heard a lot about it. I don't know, but my colleagues actually do talk about that.
that's
Yeah.
the
Yeah.
Bible. Okay.
But yeah.
So Maulik helped me to, so I used to read whenever I get stuck. I talk to him, and his influence was immense. So when I ended up in Maryland, then Raman Sandram was giving a set of lectures on ADS CFT. So it was ADS CFT without string theory. That was the aim. The basic idea was that how general. So he wrote down a conjecture that ADS CFT is every conformal field theory, strongly coupled conformal theory, obeying certain mathematical assumptions, will
Assumptions.
always have a gravitational dual description, a
Mm-hmm.
kind of a theorem. And then he
Nice.
was giving both sides how the dictionary should be understood. Of course, the completion will come from the string theory, but even at the level of classical gravity or corrections, this was giving very, very interesting result. So we were working on with Ted, me, and one of my good friend, and at that time he was visiting us, Arif Muhammad from,
Mm.
he was in, no, he was in I don't know where he was at.
Okay.
He was visiting us. So Arif, me, and Ted was working on something called membrane paradigm of black holes. So these are basically understanding whether the dynamics of black hole can be understood in terms of the ringing of membranes. Okay.
Nice.
So while we are doing the understanding of the membrane paradigm, we also realize it has a relationship with ADS-CFT.
Nice.
At the
Nice.
same time, we were handling those. I was attending those courses. Okay. So I mean, it's like whatever we are learning, we can immediately apply.
Apply it. Yeah. Yeah.
So up to 2015-16, I mostly work on, although I worked on black holes and thermodynamics, but I also looked at second law of black holes,
Yes. Yeah. Yeah. Yeah.
generalizations of the second law. And we also found with my another good friend, Aaron Wall, me, and my postdoc, Sujit, we found interesting relationship between black hole second law as well as the holography. So as if, so we show that if the second law is violated, then something wrong will happen with the holographic dictionary and vice versa. So as if the holography already knows about the second law. So that paper actually gave me a lot of faith on holography. Still, I'm carrying. Okay, counter to some of the current opinion. But I do feel the holography, irrespective of whether it is origin is string theory or not, will carry forward in future physics. Okay, that's
whenever people talk about holography, given the fact that I come from a background in atomic molecular optical physics, the holography actually has a different connotation. Of course, I later realized as I was kind of talking to some of my own fellow students as I was doing my PhD. But it's a very fascinating concept because I still am very kind of very interested. Even when I was talking to Nirmalya Kajuri and other
yeah.
people, I was always interested in knowing how that kind of intellectual arbitrage happened, so to speak, because the concepts actually have very interesting. There you go from 2D to 3D, and you essentially do similar thing here too. There is a transformation which happens. And it's a beautiful kind of concept. In Susskind, if I'm correct, is the one of the first people to do that.
I would
Or
say it is Stufft actually.
oh, is it? Okay, okay.
So just like in actual optical holography, your
Uh-huh.
aim is to encode how to encode the phase information.
Yes, you're right.
So
You're right.
here also the way it works is that first hint came from black hole entropy being proportional to area. So in ordinary quantum field theory, if you calculate the entropy by integrating out degrees of freedom or by do phase space integral or something, you generally get volume like
Yeah.
an ideal gas. Okay.
Yes. Yeah. Yeah.
So this was the first hint that the degrees of freedom in a theory with gravity in it, possibly they scale differently with the space time. They are lower dimensional. So there's an old paper by Toof and Susskind where
Okay. Okay.
they first proposed holography in that sense that quantum field theory with gravity will have this property that the scaling of the degrees of freedom will be one dimension less. It
Fabulous.
has nothing to do, it was just conjecture coming
Conjecture.
out of
Okay.
the property of the black hole entropy. What ADS-CFT does is to give a concrete realization of that conjecture. Where there is one side, you have a higher dimensional, let's say 11-dimensional string theory, which is connected to a lower dimension, one dimension lower conformal field theory. So this connection, so ADS-CFT gives the exact connections of the realizations of this principle. But the principle could be much more general than the CFT. ADS-CFT is one generalized, I would say, realization of the principle. But there could be more general realizations, which we still have not discovered.
Not discovered.
Because
Fabulous.
black hole entropy is proportional to area is, I would say, the only experimental fact we know in quantum gravity. Okay. Fortunately or unfortunately, however you interpret it. Now, so that's why I believe holography is important. But 2016, there is a major event, the discovery of gravitational wave.
Waves, yeah, yeah.
Okay, so first time we saw that nonlinear gravitational effect we will be able to access.
Mm.
And suddenly there is a search for people who can calculate cosinomal modes, who
Mm.
can calculate PN theory, who can
Mm.
calculate black hole perturbations. Okay, so suddenly the requirement utility of physicists who
Mm.
have this skill has increased. Okay,
Absolutely,
so
absolutely.
that event, the discovery of gravitational waves, was extremely important, both in India from Indian gravity community as well as so the entire shift of the gravity community first time become very data oriented.
Mm. Mm.
See, the astrophysical
Uh,
relativity is always there,
there, yeah, yeah.
but in India the gravity community was mostly theoretical. Okay,
Mm. Mm.
mathematical and theoretical.
Mm.
Gravitational waves completely broke away that.
Very correct, yeah.
Not only that, it created a new generations of gravity theorists who are good at computations.
Computation,
So
yes, yes,
these are
some
people.
fabulous, yeah.
So we were not good at computations.
Mm.
We
Mm.
were. We used to afraid computer programs. So
Mm.
we wrote basic programs,
Mm.
basic things which we know. But now I see the discovery of gravitational wave and the requirement that to
Mm.
do work in it. So it has created an excellent collaboration between people who know how to handle the data well, as well as people who know how to do the theory well. This is the first time in India they were talking. They are talking. And I
Wonderful.
think more and more you will see that astrophysicists will also enter into this discussion. Because, for example, if you want to learn neutron star, you
Mm.
need to know people who know strong field gravity well,
Mm.
people who know how to fix gauge in a perturbation theory, people who know astrophysics well, people who know computation well.
Mm. Mm.
This is a system which requires all expertise.
All expertise.
Okay.
How
So
how
now,
beautiful how beautifully it also connects things. That's a one of the fabulous aspect of physics.
absolutely.
The underlying unity among all these diversity, so to speak, and also bringing out the beautiful diversity among what we call as homogeneous unity, so to speak. That's
It
also
has changed the culture.
culture. Oh yeah, yeah.
It has
That's it.
changed the culture.
You're right.
This gravitational wave discovery, it has changed the culture of our field.
Beauty, beauty.
And
Wonderful, wonderful.
it's very, very positive. I mean,
Mm.
I am
Mm.
very, very positive that I see young people who are coming up from various institutes like ICERs, IITs, and many other places, universities also.
Mm.
They are eager to, they're not afraid of doing computations.
Competence, yeah, yeah.
Okay. Of course, we have long path to go.
Mm. Mm.
Okay. But I feel that there is now a critical community
Community, yeah.
and there's a huge crosstalk.
Wonderful, wonderful. Sudipta, also give us a gist about the contemporary questions you and your research group has been asking, and we'll also kind of broaden the discussion a little bit. Yeah.
So one of the most important question, which I think for gravitational physicists is to understand that, well, is there a life beyond Einstein's theory of gravity?
Mm.
So basic idea is that, GR is a very dangerous theory. What I mean is that if you change it a bit, okay, things go completely haywire. So, so the question is that, first of all, you can ask two types of questions. That is it possible to write down a theory of gravity which is consistent with observations, not general relativity, and is well behaved theoretical?
Mm.
Believe me, it is not that easy. Even
Mhm.
classically well behaved. See, quantum gravity, classical general relativity itself is not a well behaved theory
Mm.
in terms of quantum theory. It is non-renormalizable. Okay,
Things,
it
yeah, yeah,
doesn't have predictive powers. It may make sense as effective field theory. Okay.
yeah, yeah.
But the question is that if you go beyond GR, if you write down an effective field theory of gravity with new terms, okay, uh, is this theory consistent? Okay, is
Mm.
the
Mm.
physics beyond general relativity theoretically consistent? Okay, does it have stability? This is one question. Second question is that what kind of observation will tell us unambiguously that I am looking at a violation of general relativity?
Nice,
So
nice.
one is a theoretical question that
Mm.
what kind of extensions of general relativity are mathematically well defined.
Mhm.
Second question is that how do I observationally test? And these are related questions because you want to test mathematically consistent theories only. Okay, you don't want
Mm.
to test something which is probably doesn't make sense. Okay,
Sense.
unstable. So this is an important question which my group, along with my collaborators, we are trying to understand. Second important question is that have we detected black holes?
Mm,
Well, we hopefully are. We have detected black holes, but believe me, to say that we have detected event horizon is extremely difficult, if not impossible. Okay. So we have to come up with, of course, what we have detected is I call it detection by exclusion.
mm,
So basically, nothing else other than black hole is possible. Okay. So all the observation phenomena we have looked in the sky, like Event Horizon Telescope, black holes, X-ray observations of compact object, as well as the gravitational wave observations, are totally consistent with the black hole paradigm. Okay.
nice.
But that
Mm,
does not mean that we have detected event horizon. So the question is that what is the telltale smoking gun signature of the
mm,
presence of event horizon? Or event horizon is a bit difficult to detect for some mathematical reason, but
mm,
let's say something like a one-way surface that you
mm.
can always go into, but you cannot come out.
Come out, yeah. Some interface, some
From
kind of
interface. Uh, and it's a difficult question to answer. So
mm,
this is also people are looking out. For example, black hole perturbation theory, quasi-normal modes, provides one way to, if we measure quasi-normal mode in higher and higher accuracy, possibly we'll be say something about whether we have detected the horizon or not. The late time behavior of the black hole perturbations, if we wait for long and if you have enough sensitivity to detect, then we will be able to say something about the nature of the horizon. Okay.
nice.
These are very exciting questions. So that is also a question that have we detect a horizon or not?
Mm,
Or what are
mm,
the probes, observational probes to detect horizon? And here theorists have immense role to play because to give these tools to the observers and the data analyst, the relativists have a very important role to play. And so these are two main questions which my group, along with many other
mm.
collaborators, which we are interested in currently.
Fabulous, fabulous. So such a fascinating thing. One of the key aspects which I also kind of observed was you've been able to, bring together these expertise from your exposure in astrophysics, astronomy, from your PhD days to, let's say, the quantum gravity problems, and also, you're also uniquely placed in looking at observables and yet some abstract principles which are yet to be really, realized with the kind of reasonably high degree of accuracy and also high degree of confidence. That is another point of detection methodologies.
Absolutely.
Uh,
Absolutely.
this also means that you have to tune yourself, Sudipta, because it's not a very easy thing. Because you will either have a strong footing in one part or the other part. Here, you need to actually have this very long exposure in both areas, which you have. And how has that been? Because it also has a slightly different, different sociology, so to speak, in these kind of areas. And what has been your experience in working in these kind of two areas?
Well, definitely. So, for example, when I talk to a stringy friend of mine and when I talk to an observer friend of mine, I have to change my frame of reference. Okay. But I must say, one of the most important part of such a diversity possible, thanks to partly my PhD students,
Yeah.
there is no doubt that they well, a fabulous group of students. At the same time, the kind of postdocs I got.
Mm,
So this is something I've been telling in many, many forums that we have discovered postdoc program much late. Okay, where
mm.
world has gone ahead. Okay, so we must support our postdocs. In India,
Agree.
I say that the postdoc support is still not adequate in terms of
Agree.
salary, in terms of respect.
Respect. Yeah. Yeah.
Okay, every institute in India must have a vibrant postdoc program
Mm,
because postdoc faculty PhD student collaboration is the best way to do
best.
reverse science.
I agree with you. I agree with you. I
You
would
can
also probably include the undergraduate sometimes because they also have
Oh,
some
that's more mirror. So undergraduate, it's also a different kind of science you can
science.
do.
You're absolutely right. I agree with you. You need some level of competence and also exposure to come to a problem where
Absolutely.
you with the
Yeah.
postdocs actually are great That way,
And believe me, in India, we have not yet completely, I must say that we have not understood the importance of the
yeah.
postdocs. In
We
many
have really
institutions,
not realized the potential, actually. There's a
yes,
huge.
I think you see the science, nature of the science has changed.
Mm,
It has become much more
mm,
technical in a sense.
mm,
Okay, the techniques are more complicated.
mm.
So now a PhD student, when he completed, become a postdoc, he has so many techniques to do. That's the time he or she can do great problems. Okay.
You're right. You're
And
right.
this is the time we should use them in
Yes.
India. Right. I mean, like
Yeah,
NPDF was a very good proposal, but we should magnify it like 10 to the power 10
absolutely.
times. Okay.
Absolutely. No, even if we want to get into, let's say, technological aspect, this is one of the key points what you have mentioned, right? Because if one has a very good, let's say, industry level postdoc, it is something which people should really
Yes.
think a little bit more, because then
Yes.
you really are channeling good people to also into industries, and you can
In a
really
very
get some
in a rudimentary level, the
mm,
postdoc salary should increase.
increase. Yeah,
Increase
you're right.
by quite a bit amount. Right?
Absolutely right.
Yeah. So only then you will have good people here.
Yeah, wonderful,
And it is
wonderful.
possible. Of course, we have funding. It's not that is I'm asking something which is impossible. But the
Totally
postdoc,
correct. I agree with you. I agree with you. Sudipta, you have been also a teacher for a long time now, and I know that you take teaching very seriously. This
correct.
actually might sound very straightforward, but that is a very important part. At least I feel that being a researcher and being a teacher is kind of two sides of the same coin, and it's a very important thing. And I also, read some of the stuff what you write, the stuff what you have been also talking about. You're interested in history and philosophy of physics, and generally the history and philosophy of the world and geopolitics and everything what you have been looking at. And also, I really kind of appreciate the fact that you really think aloud and try to communicate ideas in a very lucid way. What are your perspectives on that part of it? Because teaching now actually has a different definition altogether. And I would like to just know from a person who is deeply involved and invested in this part of it.
Look, it's a very difficult question to answer because
Mm,
all
mm.
of us are trying to understand the future of teaching,
Yeah, yeah.
particularly in the era of ChatGPT. For
Yeah.
example, I have just realized I cannot give any take-home problems. Okay. So those days I
True,
used to give like take-home problem for very elective kind of courses. Then there is no fun anymore. Okay.
true, true.
But what I realized something is about teaching is that the teaching is difficult as well as easy. What I mean to
Mm,
say is that difficult it is because you want to convey your mode of thinking to another person, and another person may not even be interested. Okay. So, and also people in India, the students we get, they are a very, very inhomogeneous population.
you're right.
Some
You're right.
people are very advanced. Most of them may not have a heard of things. And
Mm,
particularly at IIT MSc program, we face this challenge
mm,
that how do we teach a group of students where many people already don't even know what is a Lagrangian?
mm, mm,
How do we
mm.
teach advanced things? So I think I have realized something that I don't want to be very fancy in a teaching. I
Nice.
nowadays follow a vanilla teaching, at least
Mm,
for elective courses. One
mm,
book,
mm.
good problems, honest communications,
Yes, yes.
reasonable number of assignments. I found that this average way of medium is
Mm,
actually, in a long run, is helpful for the students.
exactly.
So
You're right.
this is something I follow. I
Mm, mm,
insist that I will teach from a book. In
mm.
fact, I insist sometimes I tell them that all the problems will come from this book. If you solve
Yeah,
uh,
similar thing. Yes.
classical mechanics by
Mm.
Goldstein, you will get a 60,
S-
70% problem common because I force them to solve the problems.
Exactly, exactly. You're right. Similar strategy, especially the problem sets and also the set which they have to really go deep into. That's
Yes.
actually a good idea. If you know, it's a good kind of
This is
good.
something I follow. And like Griffith or any standard book,
Yeah.
you say that these are the problems I'm going to give. 60% of the problem in the exam will be
Mm,
from Griffith. So you solve the unsolved problem. Of course,
mm.
I nowadays I have changed gear.
Mm,
Now I take closed book on closed note exam
mm,
from the
mm.
open note take home kind of exams. there this philosophy has worked very well.
Mm.
One of my aim is to force student to read textbook.
Yes,
It's a
yes.
challenge. So when I teach, I say at the end of the every class, please read books. I
Yes, yeah.
actually say that I copy pasted this lecture from this book.
Yes,
So I try to impose on the students that I am not saying anything new. I copied it from that book. Why
yes,
don't you
yes.
go and read? So I believe textbook reading, installing that back to the students is a very, very important thing. Uh, I'm trying. I don't know how much I'll be successful. I also strongly believe that we should not follow a chronological approach in teaching.
Teaching, yeah, yeah.
Because if you want to teach history of quantum mechanics, you will confuse you yourself, you will confuse the entire students. Their chronology doesn't work.
Yeah, yeah, I agree with you. I agree with
But I also have really realized, at least my own understanding in relativity theory has exponentially increased when I tried and read Einstein's original paper.
you.
Because you actually understand what are the questions they were trying to
Understood.
answer. And sometimes your own understanding enhance infinitely. So this Abraham Pai's book, The Subtle is the Law,
Subtle
okay,
is a lot. Yes, yes.
which is not written for
No,
non-experts.
no.
He will assume that you know that what is a torsionless geometry, okay?
Geometry, yeah, yeah.
But that book helped me understanding relativity sometimes more than the textbook. Because I came to know for example, questions like why do Einstein thinking about general covariance? I mean, it's not like that he wake up one day, brush his teeth and started.
Exactly, exactly.
So this continuity of thought and where the Einstein is or was, this is something that my interest in history of science came from the history of general relativity.
Nice,
And
nice.
then I found the history of general relativity is very boring compared to the history of special relativity.
Yeah, yeah.
Because general relativity is one person, okay,
But yes, yes.
assumed, scattered, and then coming up with the truth. Well, special relativity,
Oh,
I mean,
spectacular.
I mean, there is one Lorentz, Poincaré. At the same time, you have Albert Einstein.
So,
And there are other people. I mean, there are many, many people.
Mac also comes in.
Absolutely. And at the same time, Maxwell was there.
Max, yeah, yeah.
Development in relativity theory,
Mm,
development of electrodynamics, understanding the nature of light. It's a fascinating history.
Fascinating. Absolutely,
Okay.
absolutely.
So the special relativity history, if you talk to, I've spoken to some friends who are
Mm,
professional history of science.
mm, mm,
For them, this theory of special relativity, the
mm.
history of special relativity is a canon. It's like a simple harmonic oscillator where you can
Yeah.
apply all the theories of science,
Yes, yes,
theory of
yes.
the histories of science. Okay, so
Absolutely.
it's a very canonical way of learning. What does falsifiability mean?
Possibility in, yeah,
What
yeah.
does it mean to say where the person is important, where the so there's this something conjecture I was discussing with one of my colleagues that what in some sense this Einstein's approach to, if you look at the the special relativity original paper, electrodynamics of moving bodies, from the second chapter, Einstein goes into the measurement of the speed of light. Like he shows that there is no gauge invariant way of measuring one-way speed of light. Then he'll talk about it's a very measurement-oriented way of writing a theories paper. For example, I don't
Beautiful.
write papers like that. Not
Yeah.
that I'm saying I'm Einstein, but what I'm saying is that it's not something a mathematical theorist will write.
Yeah,
So
you're right.
you try to understand why this special style. Why is always talking about measurement? Why is talking about mirror? Then you realize that this guy was a clerk at a patent office. He's been looking into patent applications,
Applications, yeah, yeah.
optical machines.
Yes, yes.
So no one. So now you see that there is a connection between he being at the patent office and the way he's writing his papers, his thought process, his
Thought process.
influence. Okay. So what even greats like Planck, Poincaré, or Lorentz could not able to, both Poincaré and Lorentz, particularly Poincaré, goes
Conquer
very
is.
close to the relativity.
Yeah,
He
absolutely.
got all the results
All
of
things.
relativity
Yes.
using wrong method, wrong physics. I should not say wrong. I should say that completely. So the main idea for them was this. They were looking for what is at that time called electromagnetic interpretation of matter.
Matter. Yeah,
All
yeah.
matter is basically and can be understood.
Mm.
Inertia can be understood
It's
from the electromagnetic back reaction. There's
yes,
something
yes.
called Poincare stress.
Stress. Yeah,
Very
yeah.
beautiful history. Fourth, third
Mm.
problem.
Mm.
Griffith actually discusses.
Griffith. Yes, 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 yes.
So, but they got all the results correctly. They got, for
Mm.
example, relativistic variation of mass. But it was Einstein
Mm.
who saw it from a measurement point of view. And that is possibly because one conjecture you can make that he was at a patent office.
Nice, nice.
So this is something which fascinates me. So I'm trying to think on it more, and I'm also maybe hopeful if I get time, I'll learn in a structured way.
Nice, nice.
That is
Beautiful.
difficult. Okay.
Wonderful, wonderful. These are the reasons for being a scholar, Sudipta. That really makes one's pursuit really worth it, because you can see that intellectual kick what you get out of all these things is unmatchable in any of the stuff what one
Makes
can
you
do.
happy.
Yeah.
That's all.
Exactly, exactly.
Very
Precisely
simple.
right. Very true, very true. So, Sudipta, now that we are almost converging towards the horizon of the podcast, okay, could you please give us some recommendations which you find interesting, books, art, or any aspects which you have been motivated to look at?
Well, uh, well, 1, 2, 3 infinity definitely is a
Yeah,
standard I would recommend to everybody.
yeah.
So I should recommend science fiction. For example, Asimov is one of my
Asimov.
favorite.
Yeah,
So read Asimov. That I would.
yeah.
So no, not only that, there are interesting writings by Asimov. For example, Asimov was a very interesting writing called The Relativity of Truth.
Yes, yes. In fact, there's so many
So
interesting
so
aspects. You're
that's
right.
actually a bit. There is also the Abraham Pai's book is
Yeah, yeah. Subtle is the
gem.
Lord. Yeah, yeah.
Subtle is the Lord. The
Mm,
Arthur Miller.
mm,
There's a book on theory of the history
mm.
of the special relativity is a very standard
Yeah,
reference.
standard
Uh,
reference.
Physicists can easily access
Mm,
it.
mm,
It's written for working physicists. So that would be. But I like to talk to you about a particular book. There is a guy called Alan Lightman. He was a general
mm,
relativist. Very he's one of the co-author of a problem book of relativity. Okay, very famous.
mm.
Then he became a novelist and a
Really
very
interesting.
accomplished one. Okay.
Uh-huh.
He wrote a book called The Sense of Mysterious, this Einstein's and Weber, all this
Mm,
interesting character
mm.
doing why and what motivated them. It's a bit, poetic way of looking at things, a
Look at
kind of
it.
a
Uh,
romantic, touch. Okay.
yeah, yeah. Science and human spirit. Yeah. A
But
sense of
nevertheless,
human. Yeah. He calls that. Yeah. Mm.
I feel that hardcore physicist will benefit from
Nice,
that book.
nice,
So,
nice.
and it's not very well known. So I would recommend anybody to have a look at that book,
Look
Alan
at
Lightman. Yeah,
Alan Lightman. And a sense of the mysterious.
something
Science
like that.
and
Yeah,
yeah,
yeah.
yeah, yeah. I got
Einstein.
it. Yeah.
It's a great book.
Fabulous.
Yeah.
Fantastic, fantastic. Great. These are really fabulous recommendations. I would be putting that also in the references so people
Thank you.
who are
Thanks.
looking at it
Yeah.
can explore a little bit more. So, Sudipta, it's been an absolute pleasure. I've really learned a lot and also enjoyed a lot,
Thank you.
learning
Thanks a
about
lot. I mean, giving me
things.
this opportunity to say whatever I can say. Yeah.
It's absolutely my pleasure. Absolutely my pleasure. And I'm hoping that we can also expand on the discussion going forward on these things and
Yeah.
many more occasions. I'm hoping
Yeah.
that we can have you on Pratidwani subsequently also.
I'll be very
Yeah.
happy.
Thank you, Sujita. Thank you very much. Thanks a lot.
Thanks a lot. Okay.
This
Bye.
is Pratidwani, where we try to humanize science, this time with the one and the only Professor Sudipta from IIT Gandhinagar. Thank you, Sudipta.
Thank you.